Let's solve a problem on friction so that we can understand things in a much better way. So this is the problem. So we have two blocks. This one is 20 kg. This one is 10 kg. There's a friction on the surface, and mu is 0.1. Also, there is a force acting at an angle of 30 degrees, and the value of this force is 20 Newton, right? Okay, and we have to find the acceleration of the system, which means this guy might be going down and this guy might be moving forward, or this guy may be moving this way and this guy may be moving upward. We really do not know what is the right answer, but let's assume that this guy is moving forward with an acceleration a, and by the same logic this guy is moving up by an acceleration a, and then we should move ahead and make free body diagrams. So for 20 kg, the forces acting are the tension and downward force of gravity, which is 20 g. For the other guy, which is 10, there is a force of gravity acting downward. There is a normal reaction acting upward, and there is also a force acting like this at an angle 30 degree, and this force is 20 newtons. Just to make sure we don't get confused between two ends. Also there is a tension acting, right? So most of the time there will be either the only forces that will be acting will be either tension, force of gravity, normal reaction, and friction. Just four of these which will be acting on any object. Like for this case we just have tension and force of gravity, but for this guy we have all four acting. Okay, now you see this, for this mass you can define the axis system, because now we are moving ahead and going to write Newton's law for both the masses. So let's define x this way and y this way for this mass, and similarly let's define x like that, y like that, and x like this for this mass. Now let's write Newton's equations, which are sum of fx equals max and sum of fy equals may for both the masses. Now for this mass, you see there is no acceleration or force in the x direction, so this equation is not really going to play any role, but the other equation will. So let's see, for the y-axis, what is the sum of forces? Well, tension is acting along the y-axis in the positive direction, so it's going to be T, but 20g is acting in the opposite direction, so it's going to be minus 20g is the sum of forces, and that will be equal to 20a, 20ax, where ax is actually a for this mass. So that is just one equation for 20 kilogram mass. How about the other one? For the other one, we have normal reaction, force of gravity and tension properly aligned either in the x direction or in the y direction. But you see, this force is not really, we actually forgot one force here, which is force of friction, Fr, friction. And we know Fr is given as, let's say this is kinetic friction, the whole thing is moving, is mu k multiplied by n, right? So what do we do with this force? Well, as we have already done, we can break the problem in the x and y axis, and to do that we can break this vector into the x component and the y component, which is just writing the x part of the vector and the y part of the vector. We already have discussed this. So in the x direction, the vector has 20 cos 30 degree, and in the y direction the vector has 20 sine 30 degrees. Alright, let's write the first equation for this mass. Now along the x-axis, what are the sum of forces? First of all, there is 20 cos 30 degree. Tension is acting opposite to the positive x direction, so minus t. Also, the friction is acting in the opposite direction, because we have assumed that acceleration is in this direction, and friction always acts opposite to the direction of motion. So it's going to be minus Fr equals 10a. This is the second equation. Third equation in the y direction. So we are going to write this particular equation for the 10 kilogram mass. Well, n is pointing along the y-axis, positive y-axis, plus 20 cos, no, it's 20 sine actually 30 degree, but 10g is acting in the negative y direction, so it's minus 10g. See, this is sum of forces. This is all the sum of forces in the y direction, and that should be equal to what? Well, it should be 0. Why? Because there is no acceleration or ay in the y direction, and that gives us, you see, this is some very interesting answer. We actually get n equals 0, right? Because sine 30 is what? No, I'm wrong, I'm sorry. We don't really get n equals 0. We get 10g minus 10. For the sake of simplicity, let's assume g to be 10 meters per second square. Then this is 100 minus 10 equals 90 Newton, right? So if this is 90 Newton, what is Fr? Well, we can certainly find Fr. Fr is going to be 90 multiplied by 0.1, and that gives us 9 Newton. Now we can use this Fr and put it here in the second equation. So we are left with two equations, which are t minus 20g equals 20a, and the second one is 20 cos 30 degree minus t minus 9 equals 10a. Now we can solve these two by simply replacing t from here and substituting this in the second equation. So that gives us 20 cos 30 degree minus 20a plus minus 20a minus 20g, because both of them become minus as you multiply by minus sign, minus 9 equals 10a, and that gives us 30a if we move things around, and 20 cos 30 is going to be 10 root 3 minus g we have taken to be 10, so it's going to be minus 209, and a is going to be 10 root 3 minus 209 divided by 30, right? Okay, so do we have reached the right answer? Well, no, there's something wrong. You see, this number is actually a negative number. 209 is certainly more than this number, so a is turning out to be negative, which means we started with the wrong direction of a. Well, you can say, oh, no problem, we start with the wrong direction a. We can just say that, okay, we do not have this acceleration in this direction. We can just say we have acceleration, the same number, in the opposite direction. The number we just have achieved is, if you make it positive, multiplied by minus 1, we say, okay, it's moving the other way around. But there's a problem, we cannot do that, because the moment you assume a to be going in the other direction, what happens? Friction changes sign, and all these equations, they change. And if these equations change, then your acceleration also changes. So whenever we are solving a problem in friction, it's very important to get a positive a. I hope you see my point. So we have to redo this whole problem with the other direction of a and then solve it. So let's do that in the next lecture.